All right, so coming back into our next section, graphing a quadratic function, and this is given in standard form. We have to sketch the graph of the quadratic and then state the domain and the range. So if we're stating the domain and the range, and again, what I encourage you to do is if you think you have an idea, pause the video, give it a try, and then we can always come and check to see if you're right. It's the best way to go through and learn is to try, and then when you get stuck, you can kind of watch the video until you get unstuck, and then continue to move on like that until we can figure out what the domain and range are. So we need to sketch a graph of this, and the first thing I see when I look at this is that I have common numbers here, 2, 14, and 12. They're all even, so I'm going to factor out a 2 out of this and see if that helps me visualize this a little bit more, because we want to try to get this thing into factored form. So 2, and then now I'm looking, okay, I have an easy trinomial, x squared plus 7x plus 6. The a value for that would be 1. And so I'm looking for two numbers I can multiply to give me 6. And those same two numbers can add to give me 7. And so hopefully you're thinking x plus 6, x plus 1 can work. And then now what I can do with those is I can take a look at each of these and see what the roots would be when the function is equal to 0. So x plus 6 equals 0, x plus 1 equals 0, which means x has to equal negative 6 and x has to equal negative 1. So when the function is 0, I get negative 6 as a coordinate point as well as negative 1. So that helps me right away kind of start to sketch out this graph. And we're just going to do a quick sketch on the side just to visualize what this looks like. I have my function set in terms of x. We have negative 1, so I'm going to just kind of mark back 1, 2, 3, 4, 5, and 6. And I have negative 6 and negative 1. So here and here are my two roots. Now if I know my roots, that helps me find my axis of symmetry. And once I know my axis of symmetry, then I can just plug the value back in and find out what the vertex is. So to find the axis of symmetry, what we can do is we can take both numbers, add them together, and divide it by 2. And that'll tell me the halfway point between them. So if I take negative 6 plus a negative 1 and divide them by 2, I'm going to get negative 7 over 2, or negative 3.5. So all we do is we take our roots, add them together, cut them in half. That tells us the halfway point. So our axis of symmetry for this thing is really x is equal to negative 3.5. Okay, so halfway through, my graph is going to be cut down somewhere in there. Take negative 3.5, plug it back into the equation, and that'll help us solve what we have. So f of negative 3.5 is equal to 2 times negative 3.5 plus 6 multiplied by 3.5 plus 1. And really I could have started anywhere here, right back up on top of the original equation. I could have plugged 3.5 into these ones, and they would also give me the same answer. So f at negative 3.5 is 2, and then negative 3.5 plus 6 is 2.5, and negative 3.5 plus 1 is negative 2.5. And then when I multiply all these out together, I'm getting negative 12.5 as my low value. So if I have negative 12.5 as my low value, I just have to plot out some points and come up to where that negative 12.5 would be. So I'm just going to move this down a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 will go one more. And so way down here, I'm going to have my low point. Now keep in mind my low point, it crosses my axis of symmetry. I found out that it's at negative 12.5, and so my vertex, where this thing starts to change direction, looks like it's going to be at negative 3.5, comma, negative 12.5. And so that's 1 point. Now the other thing that you should always have here, because now that I can kind of see this thing opens up, is I should have where it crosses the y-axis. And where it crosses the y-axis, that's when x is 0. So if I make x 0 here, that cancels out the first two terms, and I can see that when x is 0, then this thing equals 12. So I have a y-intercept value all the way at 12 on a high point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Way up top, I've got a point here. In terms of symmetry, I know I'm also going to have the same thing equal distance apart at negative 7. I'll have the exact same part. So that means that I can kind of sketch this thing out and see the parabola and see how it opens off of both sides. So that's my sketch. Then it wants a domain and range. When I list out my domain and my range, so x never changes. X has no restrictions on it. This thing is just going to keep opening up and can include all values of x. So x is in the set of real numbers. My range, on the other hand, has some restrictions to it. So my range, the y value here has a low point, right? And it's everything higher than that. So y has to be bigger than my low point on my vertex. So y has to be greater than or equal to 12.5, such that y is in the set of real numbers. So that's my domain and my range. I have another one here just for you guys to try, so I encourage you to try it out first. Pause the video, give it a try, and come back when you're ready. Alright, so for our next part, we're going to sketch the graph of the following one. We're going to go through the same kind of principle. So I have f at x, and then again, I'm going to look for a common factor here. I can see that I can factor out a 3. So I'm going to take out the negative with it as well because I want my x squared term to be positive if I can when I factor. Take out the 3, I'm going to have x squared minus 2x plus 1. So I'm going to look now and try to see, okay, what can I do to graph this out? I'm going to open this up to two binomial terms and think, what two things can I get that can multiply to give me 1? And those same two numbers add to give me negative 2. And so when I kind of picture this and see how this looks, I need two negative numbers because they have to multiply to give me a positive value, but they have to add to give me another negative, and then it's just 1 and 1. So really, what is this saying? As these numbers are both the same, x minus 1 and x minus 1, this is actually telling me that the parabola is only going to cross the x-axis at one spot. So basically this is saying that there's one root. So I have a root value. X minus 1 is equal to 0, so x is equal to 1. So when I sketch this thing out, I know right away quite a bit of information already. I have my x value, I have my function, and I'm just going to plot out a couple of points so I know that x is equal to 1 for one of my roots. And really, there's only one root. Now, does this thing open up or down? Well, there's a negative here, so that tells me this thing's going to open down. So let's figure out where it crosses the y-axis. That should be our next step. So if this thing crosses the y-axis, remember when x is 0, so when x is 0, I'm going to have negative 3 times 0 plus 6 times 0 minus 3. So really, when the function is 0, I can see that this thing crosses at negative 3. Now, we could then go through and we can figure out, really, if this thing has one root, this is the axis of symmetry, right? Because it's the middle part. Remember, when we're finding axis of symmetry, we look between the two roots. Well, when there's only one root, that tells us that it must go straight through where that one root is. And remember from before, I said that parabolas are very symmetric. And so because they're symmetrical, if I know that I went left one place from my axis of symmetry, I got a value of -3. If I go right one place and go down, I should also have a value at -3. And I could double check that if I plugged in what is my function value when I get 2, or f of 2. And I encourage you that if you want to check it out, just plug 2 into your x values and see what you get. And it's going to work out to be -3. And so now I've got my little sketch that I can use here, going through and plotting my points. So I can then also say what the domain and range is, similar to the last problem. Domain for x would be x is in the set of real numbers, and the range value for this. Now before we had that y was greater than. Now here though, remember we have a maximum value, so I need all the y values that are going to be lower than that include the quadratic. So y in this case is going to be less than or equal to 0, because that's the highest point that I have, such that y is in the set of real numbers. So that's my domain and my range for this part. So I'm going to pause this video and come back when you're ready to move on to the next one.